Hi, my name is Jace, and I'm a content contributor with Code Academy. We're going to walk through the project, Matching Memory with React Redux. This project is part of the Connect to React with React Redux module. React Redux is a UI binding library for applications and allows React to handle and optimize UI rendering, while Redux handles global application state. For this project, you will need to be familiar with JavaScript fundamentals, JSX, React, React DOM, and core Redux API methods. You will also need to understand the React Redux library, including the provider component, selectors, and the hooks useSelector and useDispatch. The application in this project is almost complete. The Redux implementation is complete with a store, reducers, and action creators. And there are several React components. Each of them need a bit more logic to render what is necessary for the application to work. Before we start the walkthrough, let's take a quick look at the application. Here we are in the project workspace. There are a number of tabs open with files that we will work on. Let's start by looking at the Redux implementation, and for that we need to open up the store file. We won't be working with this file during the implementation of this project, but reviewing this file gives us information on the application state managed by the Redux store. Looking at the combined reducers argument, there is only one reducer passed, board reducer, and it is under the namespace board. This means that when accessing data in our selectors, we will use state.board. That's it for the store file. Moving on to board_slice.js. The initial state is an array of 12 card objects, each with the properties ID, contents, visible, and matched. Let's move down to this utility function. It is called by the setBoard action creator and keeps any random logic out of the action creator body. These three action creators return the action objects for the three actions: setBoard, flipCard, and resetCards. Now moving up to the reducer, we have the setBoard action, which receives an array of randomized words as its payload and returns an entirely new array of card objects. The resetCards action returns an array of card objects, where the visible property is set to false. flipCard contains most of the gameplay logic. It receives the ID of a card to flip over and sets the visible property of that card to true. It then goes on to check if two cards are visible, and if so, do they have the same contents. If this is true, both cards have their match properties set to true. We will create a few selectors at the bottom of the board slice file. Now let's take a look at the React components. In app.js, the app component renders two components, the board component and the score component. Looking at score.js, the score component displays the game score. In board.js, the board component renders a group of card row components to represent a grid of cards. The row value is used to iteratively create the board layout. In cardRow.js, the card row component is used to organize each row of cards. We will not be working in this file. In card.js, the card component has the display logic for each card using the props ID and contents. Lastly, in index.js, we have the entry to the application and where we will start with the walkthrough. The first set of tasks give the application access to the Redux store. The rest of the tasks in this project won't accomplish anything if we don't perform this first. Let's start by importing the provider component from React Redux. This import and all others in this project will be named imports, so we need to put the import in curly braces. With the provider component now imported, we can wrap the root application and pass the imported store through the prop, aptly named store. Now we can move on to the logic to access the Redux store. The next set of tasks work on setting up the board layout using the card objects in the state. This will require a selector at the bottom of board slice. Before we write the selector, let's take a look at an example of the array our selector will want to return. The board component works on an array of objects where each object holds a card's ID and contents. As we will see, the selector will map over the array of card objects to return just the ID and contents of each. Since we plan on using this selector in a separate file, we'll make it part of an export statement. By convention, we'd like selectors to start with the word select, and this one will be called select board. We'll set this equal to an arrow function with state as the only parameter. The body of the function will be state.board.map, and the map method's callback function will have the parameter card and will return an object that contains the card ID and contents properties. It's important to note that the object being returned from the callback function is wrapped in parentheses, so the object curly braces are not mistaken for the function body. We now have our first selector to be used within the board component. Moving over to board.js, we'll retrieve the array returned from SelectBoard and use it to finish the board rendering logic. First, let's start with some import statements. We will need useSelector from React Redux, as well as the selector we just implemented from BoardSlice. I know for me it can be a challenge to write out the path strings for the files and application structures like this one. Thankfully, BoardSlice is in the same directory as this component, so a / is all we will need to prefix the file name. Moving into the component definition, we need to retrieve the data supplied by SelectBoard. It's good to put all variable definitions and data retrieval first, so on this first line, we'll define current board and set it to useSelector with SelectBoard as the argument. So now we can use the current board array to finish the board creation logic. The first thing to do is set number of cards to the length of the array. If we run the code now, we will see the board rendered with 12 card components. These components haven't been passed any information yet to be useful, so let's do that now. The iterative logic at the bottom of the board component uses the utility function getRowCards. This function returns an array of card objects which is held in row cards. Row cards is then passed as a prop to a card row component that is pushed to the array content. In the case of a board with 3 columns and 12 cards, 4 card row components are pushed to the content array and returned by the board component. The logic we need to complete lies within getRowCards. GetRowCards has one parameter, row. It holds a value used to calculate the index number of the card objects to be returned from the current board array. The array index is called cardIndex. Using cardIndex with the current board array, we can repeatedly push card objects to the return array, rowCards. Inside the push method, we need to replace the empty object with current board indexed with cardIndex. When we run the code, we will see the same grid of cards, but now each card component has their ID and content data. Now that we've completed that, let's move on to the next set of tasks. With the board rendered, we now want to move to working on the card component rendering. If we go to the BoardSlice file and look at the initial state, we see that the visible properties are set to true. For this set of tasks, we're going to render the contents of the card if its visible property is set to true. Moving to the bottom of the slice file, we will now define a new selector that returns an array of card IDs whose visible properties are set to true. Like the last selector, I'll make it an export statement, and this one will be named SelectVisibleIDs. A good selector name should be short but descriptive of the data it retrieves. The parameter once again will be state, and this time we will filter the state array before returning any data. I'll start by typing out state.board.filter.map. For the filter callback function, I'm going to name the parameter card, and the function condition will be card.visible. This will now send the map method an array of card objects with the visible property set to true. The callback for the map method will now return just card.id. Being comfortable with JavaScript's array methods can take some time, but is important. If you need a quick refresher, feel free to look up the docs online to remind yourself how they work. Now that we have access to an array of visible card IDs, we can go to card.js and retrieve the data for proper rendering. Once again, we're going to start with the imports. Since we're retrieving data, we need to import useSelector from React Redux, and then select visible IDs from BoardSlice. This path is a bit more involved, so we can check in on our directory structure 1, 2 levels up. Okay, and that's it for the imports. We can now move into the component definition to retrieve the array of card IDs. Here we will define a variable, visible IDs, and set it to useSelector with select visible IDs as the argument. By default, each card has card text set to an image, the Codecademy logo. Using conditionals, we can change what is contained in card text, which is exactly what this first if statement is for. Using the includes method of visible IDs array, we can test if the card ID is visible and then set card text to the card contents. When we run the code, we now see all the contents of the cards shown since the application's initial state has all the card object's visible properties set to true. Let's go back to BoardSlice to look at the initial state to see that the order of the content matches what is rendered in the browser. At this point in the project, we have only rendered what has been set in the initial state. It is time to let the user change the state by dispatching an action to hide the cards and randomize their order. If we go to BoardSlice, we can find the action creator, setBoard. This action creator randomizes the array of words, adds it to the action object payload, and then returns the action object. To set up the game, we're going to dispatch an action from the app component using the Start Game button. Once again, we need to begin with a couple imports. This time we'll import useDispatch from React Redux, and then the setBoard action creator from BoardSlice. One more time to the directory structure to get the correct path. BoardSlice is inside features, and then the board directory. Let's recall that useDispatch doesn't dispatch actions, but returns a reference to the method that does dispatch actions, the Redux store's dispatch method. So let's define the variable dispatch to hold this reference. Now inside the Start Game handler, we can call dispatch to dispatch the action returned by the setBoard action creator. When we run the code and click the Start Game button, we see that all the cards are now flipped over. That is because setBoard sets all the card object's visible properties to false. To start the gameplay, we need to dispatch an action to flip over the cards. Moving back to the card file, we'll add some imports. Use dispatch to the React Redux statement, and flip card to the BoardSlice statement. Under the visible IDs definition, we define our dispatch reference. Now we want to dispatch flip card inside the flip handler function with ID as the argument. Flip card is an action creator which takes ID and adds it to the payload of the action object to be dispatched. When we run the code and start the game, we can flip over cards and view their contents. We can confirm that the words are now in random order. The last task in this section, we need to limit the number of cards visible at one time to 2. This is done by performing a length check on visible IDs in the third if statement. If the length of visible IDs is equal to 2, click will be set to a blank function, which means the flip card action will no longer be dispatched from any of the card components. Moving back to the app component, we will dispatch another action to reset the visible cards. This will allow us to continue the gameplay. Since useDispatch is already imported, all we need to do is import the action creator. Add reset cards to the board slice import statement. Moving into the component, we already created a reference to the store dispatch, so we can go straight to dispatching the action inside try again handler. We'll do this using dispatch and the action creator reset cards. The reset cards action sets the visible properties of every card object in the state to false. This in turn re-renders the card components and hides their contents. After running the code and starting the game, we can see that 2 cards can be selected and then reset using the Try New Pair button. Now the card flipping can continue, so let's work on the final gameplay element, matching cards. In the board slice file, we need to implement one more selector that selects an array of the card IDs where the card objects' matched properties are set to true. As noted in the task, select matched IDs is the same as select visible IDs, except the filter callback is going to test the matched property. Moving back to the card component one last time, we will add select matched IDs to the board slice import statement. Then, define a variable matched IDs and set it equal to useSelector with select matched IDs. Now each card component knows which IDs are matched. There are 3 things we need to happen when a card is matched. We want to turn the text to green by setting card style to matched, show a card's contents, and disable the click function. We can accomplish the first goal by putting an ID membership check on matched IDs in the second if statement. When a card is matched, its content style will change. The other 2 goals are accomplished by adding an OR to the first if condition and making an ID membership check in matched IDs. This makes matched cards act the same as visible cards. The OR operator is important to keep the card contents visible on matched cards when reset cards is dispatched. Once a card is matched, it stays matched until we start the game over. When we run the app, we can check that all the gameplay is implemented. Let's see if we get some matches. We have a match, and the contents of the cards are green. The last set of tasks implement the scorekeeping for the game. An easy way to keep score is to count the number of matched cards. Let's go to the score.js file. To get the matched card IDs, we need to import useSelector from React Redux and select matched IDs from board slice. Let's make sure we get the correct path. Up 1 level, then in the board directory. We can now define cards matched and set it to useSelector with select matched IDs. Now that the component has an array of the matched IDs, we can use it to render the number of matched cards. Let's replace this 0 with the length of cards matched. When we run the code, we first see that the app initializes with all the cards matched and the score 12. We start the game, the cards are hidden, and the score goes to 0. When we get a match, the score changes. Now let's move on to the 2 challenge tasks. The first task proposes hiding visible cards by clicking any of the cards instead of just the Try New Pair button. Since we'll be dispatching the same action as that button, let's go over to the app component and copy the handler function and paste it into our card component. Since we're now calling the action creator reset cards, we need to add it to the growing board slice import statement. Now we need to see if we have a conditional set up where the try again handler can be called. Since we reset the cards when they are paused at 2, we can call the handler inside this third if statement. Now, when we run this and start the game, we can select 2 cards, and then reset using any card on the board. Let's make sure it works with a visible card. Now let's get a match so we can click a matched card. All the cards reset the unmatched cards since the condition tests the length of the array, not the contents. Now, moving to the second challenge, we're being asked to assign the no match selector to card style when two unmatched cards are visible. I'll say that again. Set card style to no match if two cards are visible and the cards don't match. Instead of trying to figure out if we can fit this into an existing condition, let's create a fourth if statement. Inside the body, let's set card style to no match. Now for the first piece of the condition, the length of visible IDs equals to 2. Let's add another condition separated by an AND operator. This condition will check that the ID is not in the matched IDs array. Run the code, and then make sure the code works. Here we can see the text turns red when there's no match. And we still get a green when there is a match. Thank you for taking part in this walkthrough. I hope it helps with your project implementation and future projects. Happy coding!